Okay, so now we're going to factor out the greatest common factor. Oh, I need to pass. Okay, example 1, number 1. Look here, please. So, on the warm-up, we were multiplying. Factoring is the opposite of multiplication. So we are undoing the multiplication when we are factoring. Okay, so it's the other direction. So let me go back to this here. So factoring is going from, let's say, this one right here, this 18p squared plus 21p, and going back to the question, going back to there, from here to there, here to there. So we're going to do factoring today. So first one that we're going to do is factor out the greatest common factor. So greatest common factor, we're looking for a number and or a letter that we can take out of both of those terms. Ira? 3? Any letters that we can take out of both the terms? Or is it just 3? Okay, and she's right. No number bigger than 3 goes into them, right? Because we want to look at the biggest number that goes into both of them. So it's a 3. So we are thinking 3 times what gives us 24? 8. So if you have trouble with your multiplication table, you may need to have a calculator. So 3 times what gives us negative 15x to the third? Minus 5x to the third. We didn't take any x's out there. Does that make sense? So this is factoring going the other direction. This direction would be multiplication. So number 2, we have a number and or a letter that goes into all of those. So if we could raise our hand, because when somebody shouts out the answer, then everybody else stops thinking. I don't need to think. Somebody else is going to answer. Good intentions, I know. So what's the greatest common factor on this one? Yes. 1 is the only number that goes into all of them. Is there a letter that goes into all of them? N. So we can take an N out of all of them. So we're thinking N times what gives us 20n to the 6th? 20 n 5. So let me go back on this for a moment. N times n to the 5th. Why is that n to the 6th? When we have n to the 5th, there are 5 n's and 1 n, and there we have a total of 6 n's. So, Anais, I love what you just said. What could we do with those exponents? What exponents assumed to be on the 1 first? Or should be on the n? What? I think it was you that said it. So how could we get the exponents there? Yes, that's right. So we could just add them rather than writing it out like this. We can add them. Yep, good. So 1 plus 5. This is a 1 plus 5 gives us n to the 6th. So now the next one, quiet please. We want to look at n times what gives us negative 3n squared. Anais knows. Yes. Yes, Hayden. What is it? Yes, negative 3n. So again, negative 3n times n gives you the negative 3n squared. You add those exponents, 1 plus 1 gets you back to the 2. And then n times what gives us 15n? Positive 15. Isn't that right? Okay, what about number 3? East knows. Let's see. Omar, do you know a number and or a letter that will go into all of those? Is there a number also? And we want the biggest number. Not sure. Somebody else? 9. So what's the greatest common factor here? 9n. So we can take out an n and we can take out a 9. So 9n times what gives us 9n to the 5th? n4. Again, you can add those exponents. This is a 1 plus 4 gives us the 5. So okay, so 9n times what gives us 36n squared? 4n. Again, we're adding those exponents. And then 9n times what gives us 9n? 1. So plus 1. Questions there on that? Please let me know if you have questions. Okay, and last one, number 4. Biggest number and or letter or letters. Say that again. So are there more than one K that we can take out? 2 of them. Okay, so we like this first term here, this one. When we factor it out, we like it to become positive. So in order to make that positive, when we go to factor out, we want to take out a negative 5k squared. So negative 5k squared. And then what would we multiply that by to get negative 20k to the 4th? 4k. How many k's? 2. So remember, the 2 plus 2 gets you back to the 4. So again, we like this first term here. Let's see if the pointer will show if I do that. So this one here, we like this one to be positive. So that's why we made this one here negative. So negative 5k times what gives us negative 10k to the 4th? Nate, sorry. Minus 2k squared. Good. Is it minus or positive? Positive. And then negative 5k squared times what gives us 30k cubed? 6k. Because remember, it needs to add up to 3. Does that make sense? And it would need to be negative 6. Because negative times negative gives you the positive. And then what goes here? Plus 1. Negative 1. Yep, minus 1. Okay, go ahead and do the U try.
Oh yeah. I live like 5 minutes from because we're ad looking. Which is like a fun and I give them my headset on and you put your head down you can talk to each other through the headset. It's like a walkie-talkie system. Basically, it's like weights on the ground up, so like when you're in the car, you can hear it.
Okay, so this is what your answer should be. Any questions on that? There. Let me go back to this last one. I meant to change this to a 5. So then this would be still, everything else would be the same except this would be a 3. Otherwise, we'd have to add those two terms together. Okay, so number 6. Can we take out a greatest common factor on that one? No. So when we have an x squared, when we have an x and a number like that, 3 of them, we can use what's called the x to factor. So it is like a couple of those examples that we did. So we're looking at the last term here, negative 63, along the constant, and then the coefficient in front of the x, the negative 2. We're looking at what multiplies to this that adds to this. Only 2 numbers. What multiplies to negative 63 that adds to negative 2. What's the number that goes into 63?
I remember this.
Yes, Emma? Yes. So negative 9 and? Thank you, those of you who are sitting quietly. So now when we go to factor it, we're going to use this x to help us. It just organizes it for us. So we're going to put a negative 9, positive 7, because this is assumed to be a positive, and then x times what gives us x squared? X times what gives us x squared? Yes, x times x. So this is an x here. So this is fully factored. So what I'm going to do on this one, and this one only, is that I'm going to go back and multiply it out. I'm going to do it in a different color because I'm going to erase it after. So if we did our claw, x times x is x squared. X times 7, 7x. Negative 9 times x, negative 9x. And negative 9 times 7 is negative 63. We added our like terms. Notice you get back up to the original. So when you've got that x squared and an x, you can use that, this X here, this big X, to organize your information to see what these two would be here, these two expressions. I'm going to erase this because our answer is just what's in the red there. So could I write that answer as x plus 7 times x minus 9? So I switch the order of those two expressions. I heard one person saying yes, and I saw one person shaking their head yes, and yes, that's correct. Anybody know why? Ooh, Katie, yes, because it's multiplication. That's right. So when we multiply, for example, if we multiply 9 times 7, that gives us 63. If we multiply 7 times 9, does that also give us 63? Yeah, so the order doesn't matter when we're multiplying. So now on this next one, is there a greatest common factor we can take out? No greatest common factor, is there? No letter or number. So we're going to use our x again. What number goes on the top? What goes on the bottom? 90, the last number, and negative 19 goes down here. So always, this is always the constant, the number, and this is your coefficient in front of what's called the linear term. So what multiplies to 90 that adds to negative 19? Yes, negative 10 and negative 9. So what would our factors be? Nice. Good. And could we switch that order? Did we write it as r minus 10 and r minus times r minus 9? Yes. Okay, any greatest common factor on number 8? No. We're going to use our x to organize what goes on the top, what goes on the bottom. Let's just go. What goes on the top and what goes on the bottom? What goes here? What goes here? 12 and 7. And so what numbers work there? Anybody? 4 and 3. The only numbers that work. When we do this, there's only 2 numbers that work. And so then our answer, what would our answer be? Asan, can you give us our answer? This helps us organize. And plus 3. Does that make sense? Because this is positive. Good. And if we multiplied that out, what would we get when we multiplied out? Good. We get back to this here. This n squared plus 7n minus, plus 12. Okay, number 9. Does that one look the same? No. So factoring is all about patterns. We're looking at patterns. So this pattern is different. So how might we get 2 terms like that? It's separated by a minus. You're all over this factoring stuff. Good for you. Do you see it? Go ahead. Maybe nobody else saw it. Go ahead. Take the square root, So what's the square root of 36? 6. So 6 and 6. And then what's the square root of x squared? X. So I have x and x. And then what will the signs be in order to only get a plus and a minus? That's right. And again, that order could be switched. So notice this is a perfect square here and perfect square here, separated by a minus. That's called the difference of 2 squared. Can I go on to the next one? Okay, 25a squared minus 9. Greatest common factor? No letter or number that goes into both of them. Using the difference of two squares. So what's the square root of 25a squared? 5a. What's the square root of 9? 3. And then in order to not get that middle term there, plus and minus. And last one, number 11, same idea. Somebody want to tell me what the answer would be on that? Picking this up quickly. This is square root of 49x to the 4th. Leah.
I said 9x squared plus 5 and then 9x squared minus 5.
I like the x squared plus 5 and minus 5. 49, so I think you were thinking of 81.
Oh my bad.
That's all right. You got the x squared, which was hard. It's the square root of 49. 7, so 7 and 7. Okay, go ahead and do the U try. Those two U try problems. Okay, here are the answers to number 12 and 13. Questions on that before we go into the very last example. So I can answer that later if you have quick questions. So, last one. When you have your homework assignment, they're all going to be mixed together. So the first thing you want to do is you want to see if you can factor out a greatest common factor. So number 14, can we factor out a greatest common factor? Yeah, and when you factor out that greatest common factor, if you look at that very last term, that usually gives you an indication of how many variables you can take out. It doesn't always, but it usually does. So see how there's just a p here? We can take a p out, and then what number is the biggest number we can take out of here? 4, good. So we could also take out 2, but we want to take out the biggest, which is 4. So this would be 3p squared, 10p, and minus 2. So number 15, can we take out a greatest common factor there? We can't. So then we're going to go, so you see that we have 3 terms there, m squared, m, and then a number. So we're going to use our x. So what multiplies to 45? That adds to negative 14. Yes. So if you have trouble with your multiplication tables, you'll want to use your multiplication rules. When you have a number 45 like this, and you're thinking about what multiplies to 45, it ends in 5, which means that 5 goes into it. So it's negative 9 and 5 here. So m minus 9, m plus 5. Yes? It's supposed to be negative, thank you. Both negatives. To give you a negative 14. So now on the last one, what's the square root of 16k squared? 4k, so just 2 terms here on this one, no greatest common factor, so we're going to go the difference of 2 squares, and then minus 1 and plus 1.